This is a linear graph that shows the relation between two variables, x and y. At this point of the line, the x position is 3, while the y position is 2. So this point is called 3, 2. At this point, the x position is 6, while the y position is 4. Moving up again, x and y are 9 and 6 respectively, and this point is 12, 8. Now we can easily find the gradient or slope of this graph. This is the change in y per unit change in x. As x changes from 0 to 3 to 6, 9, 12 and so on, y changes from 0 to 2 to 4, 6, 8 and so on. This means that when the change in x is 3, then the change in y is 2. Therefore, the gradient is equal to the change in y over the change in x, which is 2 over 3. Now that we know the gradient, let's find the equation of the line. The standard equation of a straight line is this, where c is a constant number that represents the intercept that the line makes with the y-axis. In other words, c is the value of y when x is equal to 0. To find the value of c, replace x and y with any point on the line. For example, y is equal to 2 when x is equal to 3. 2 over 3 times 3 is 2. Subtract 2 from both sides and c is equal to 0. This means that there is no constant number, and this is correct because on the graph, we can see that the line intercepts with the y-axis at the y position of 0. Therefore, the equation of the line is y equal to 2 over 3x. If the y-intercept was 2, for example, then the line would intercept with the y-axis at the y position of 2. The intercept could even be a negative number or a fraction. It determines the line's position on the graph. As you must have noticed, all these lines have something in common. They have the same gradient of 2 over 3, which means that y changes at the same rate on all 4 lines. As a result, the lines move in the same direction and never meet, making them parallel to each other. If the gradient is 0, then there would be no x in the equation, making y equal to a constant number. So y would always remain the same, no matter the x position. As a result, the lines would be parallel to the x-axis. In other words, the gradient is only 0 when there is no change in the y position. Now you might need to find the equation of a line where you know only one point of this unknown line. In this case, the only other thing that you need to know about the line is its gradient, and you are good to go. This formula can only be used when 2 or more points on the line are known. Instead, this is another formula of the gradient that you can use, where a and b are the x and y positions of any point on the line, respectively. So, a is equal to 5 and b is minus 2. Multiply both sides of the equation by x minus 5. Minus 1 times x is minus x, and minus 1 times minus 5 is 5. 5 divided by 5 is 1. Subtract 2 from both sides of the equation, and this is the equation of the line, where the gradient is minus 1 over 5, and the y-intercept is minus 1. Finally, the equation of a vertical line is simply its x position, which remains constant. The line's change in y at this point approaches infinity because the line goes up or down forever. There is no change in x because, as mentioned before, x is a constant number. So the gradient is equal to the change in y over 0. And dividing any number by 0 is undefined because it is just impossible. In conclusion, a vertical line has no valid gradient. If the line goes upwards from left to right, then the gradient is a positive number. If the line is horizontal, then the gradient is 0. And if the line goes downwards, then the gradient is a negative number. This is all you need to know about the gradient and equations of linear graphs.